Alright guys, the topic for today will be number plane set 14 to 17. So we'll be covering 4 topics in this video. So let's look at the graphs first. So when you're graphically representing an equation, you'll be using a Cartesian plane. So this over here is a Cartesian plane. Okay, so what we do with a Cartesian plane is graphically represent an equation with the x and y coordinate. So the x coordinate represents the horizontal distance from the origin, and the y coordinate represents the vertical distance from the origin. And the origin is 0, 0, the point over here right in the middle. Okay, so over here it says the point 0, 0 is called the origin. Okay, for example, let's look at coordinate L here. L is 5 units to the right of the origin and 2 units to the above of the origin, to the top of the origin, right? So L will be 5 to the right and 2 above, which gives us 5 and 2. Let's do the same for M. M is 1 to the left and 3 above. So if it's 1 to the left, it's -1, and since it's 3 above, it's positive 3. Let's look at N. How many units to the left is it from the origin? 4 units, so we get -4. And how many units down is it from the origin? 3, so we have -3. So these are the ordered pairs representing each coordinate. Okay, and all you have to do is put the x coordinate first, comma, and then y coordinate. Okay, so if we have a look at P over here, it will be 1 to the right, so 1, comma, -5. You look at the y coordinate here. Okay, let's move on to the next one. We're looking at distance between 2 points using Pythagoras. Okay, so we had A at 1 and 5, and B at, where's B? 4 and 9. Okay, so we've got these two coordinates, and we're looking for the distance between these two coordinates. We know that this is a right angle triangle, right? So if we have a right angle triangle, to find the hypotenuse, what we do is we use Pythagoras theorem, which is c squared is equal to a squared plus b squared. And using Pythagoras theorem, we know that this is A, the 3 units, and this is B, the 4 units. So we can look for c squared using a squared, which is 3 units to the power of 2, plus 4 units to the power of 2. What's 3 units to the power of 2, which gives us 9, and then 16, which comes down to 25 units. And since it's c squared, we square root it to get 5 units. And that's our distance from A to B. There we go. And that's how we find the distance between 2 points. It's always not so easy to find out the distance by using the 2 lengths. That's why we use this formula over here. So mathematicians have reduced it to a formula so that it's easy for us to figure out the distance between 2 random points. Okay, so we have 1 and 5 over here, so A is 1 and 5 and B is 4 and 9, just as before. What we do is x2 minus x1 squared, so we'll say this is x1 and this is y1 and this is x2 and this is y2. Okay, so we know that x2 is 4, and then minus x1, which is 1, gives us 3, and we square it. And we have y2, which is 9, minus 5, which is y1, and square it. Okay, so what's 4 minus 1? Gives us 3 squared. 9 minus 5, 4 squared. We get the same as before when we did the normal Pythagoras. Okay, so we have 9 plus 16, and add them up, which gives us root 25, simplifies to 5 units. As easy as that. Okay, so it doesn't matter which coordinate becomes x1 and y1. This could be x2 and y2, and this could be x1 and y1, and you can still get the same answer. Okay, let's do it a different way for this one. Okay, we can make this x2 and this y2, this x1 and y1. Okay, now let's do the maths. x2 minus x1, which gives us 3 minus 1, which is 2. And we've got y2 minus y1, negative 1 minus negative 5, which gives us positive 4. Okay, we don't have to worry about that just now. We'll put the square root as well. 3 minus 1 gives us 2, 2 squared, plus negative 1 minus negative 5 gives us 4, which is 4 squared. And we're ending up with 4 plus 16, which gives us root 20. Oops. Okay, root 20. We can simplify this to root 5 as well. And always remember to say units. Okay, and that's it. That's how we use the distance formula. Now let's look at midpoint formula. So to find the midpoint between 2 points, 2 coordinates, what we do is we add up the coordinates for x1 and x2 and divide it by 2. That's how we find the midpoint of anything. If we have 3 items, we add up all the 3 items and divide it by the number of items, which is 3. And that's what we do for the coordinates as well. We take x1 and y1. Let's do it for this one and see what we get. x1 and y1, and this is x2 and y2. Okay, let's add up these two numbers. What's x1? 1. x2 is 5. 1 plus 5, and we divide it by 2. Okay, what's y1? Negative 2. y2 is 6. Negative 2 plus 6, and we divide it by 2. What's 1 plus 5 is just 6. 6 divided by 3 is 3. Sorry, 2 is 3. And then we have negative 2 plus 6, which is 4. 4 divided by 2 is 2. So our midpoint is 3 and 2. All you have to remember is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It doesn't matter which one is x1 and which one is x2, as long as the 1s are together and the 2s are together here. So like that and like that. Makes sense? Alrighty, let's move on. Let's do this example. Make this x2 and y2, and make this y1. Sorry, that's not y1, that's x1. Make this x1 and y1. Alright, add them up. Divided by 2, that's our x coordinate. Let's add up the y coordinates. Divided by 2. Okay, negative 3 plus negative 1 gives us negative 4. Negative 4 divided by 2 is negative 2. 5 plus negative 2 gives us 3. 3 divided by 2 gives us 3 on 2. And that's our answer. Okay, you can write it as a mixed fraction if you want, but you can leave it as is. Alright, graphing straight lines. Let's have a look. So if you're given an equation in algebraic form, let's say for example y equals 2x plus 1, the y value always corresponds with the x value that we've been given. Okay, so they're saying that the y value is twice as much as the x value plus 1. Okay, so for example, if we have 5 as the x value, okay, what we do is we times this by 2 and add 1. So 5 times 2 plus 1, which gives us 11. Okay, that's how we figure out what the y value is and graph the lines according to the coordinates that we get. So the coordinate of this x coordinate will be 5 and 11. Okay, and they've given us the value for 10, 10 and 11, and so on and so forth. Okay, another way that they can give you values will be in table form. So they give you the x values and the corresponding y values, and what we just need to do is we need to see which numbers are corresponding with the y value and come up with an equation. An easier way to do this is find out the gradient by using y2 minus y1 over x2 minus x1, and we've got the x-intercept here. I'll just quickly do that for you. y2 minus y1 will be 5 minus 3, and x2 minus x1 will be 2 minus 1, which is 2 on 1. We got our gradient to be 2, y is equal to 2x, and our y-intercept is 1 because x is 0. Whenever x is 0, the y-intercept, we can find the y-intercept. So we have y is equal to 2x plus 1 as the answer. Okay, and these are some other ways you can graphically represent an equation. Let's have a look at some of these questions. These are pretty easy. What you do is you look at the relation y is equal to 3x minus 1 and come up with a table. When you're coming up with a table, what you need to do is you need to substitute x with the value that they've given you. So if you're substituting x to be 0, what you're left with is -1, because 3 times 0 is 0, and you're left with -1. So you write -1 in the y box there, and you do the same for the rest of the numbers, and so on and so forth. Let's try doing 3 here. So we substitute 3 to be x. 3 times 3 minus 1, which is 9, minus 1 gives us 8, so that's the answer. That's what we do. Alright, let's keep going. We've got some further examples. They're graphically representing y is equal to 3 minus x. So you can graphically represent it, and you can use the table form as well. Okay, let's have a look. These are pretty easy. You're substituting values to get what the y value is, so substituting all the x values in the table. Let's try doing number 6. When x is equal to 6, what's the y value? We do y is equal to half times 6, which gives us 3. Okay, that's how it works. Alrighty. Two special types of line graphs. Okay. Draw a horizontal line parallel to the x-axis, which cuts the y-axis at number C. Okay, if you have graphs in terms of y, it's always horizontal. Okay? And why, you may ask, because let's have a look here. If y is equal to 3, the y value will be 3 for the whole line. It doesn't matter what the x value is, the y value will always be 3. And for y to have the value of 3 for the whole line, it has to be horizontal, because at 1 it's equal to 3, at 2 it's equal to 3, at 3 is equal to 3. So that's how you know that y is equal to 3 is a horizontal line, and x is always a vertical line, and we'll show that in the graph over here. So if x was equal to 2, the line has to have an x value of 2 for the whole line. Okay, so if we start the line from here, it would have the value of x no matter what the y value is. The x value will remain the same. That's why it has to be a vertical line. So remember this. Equation starting with a y and a constant will always be a horizontal line. Equation starting with x and a constant will always be a vertical line. Okay, but horizontal and ver for vertical. Okay, let's keep going. That's what we discussed over there. That's x when x is equal to a constant. It's a vertical line, see it's always -3 here. And those are the easiest type of graphs, because all you need to remember is when 1 is equal to a constant, let's say 2, it'll always be here. Okay? And the line will keep going on. Okay? And let's say the x value was, hold on. Let's say the x value was -3, it will be something like this. The x-intercept will be there, and the line will keep going on. Okay, that's it. What if we were to find the intersection of these two lines? What do you think this point will be? It's pretty easy. You look at the x coordinate over here and the y coordinate over here, which will be -3 and 2, and write it as an ordered pair. Okay. Right, let's go on to something a bit more challenging. We're determining if a point lies on a line. To see if a point lies on a line, we're given the equation, and we're given the point. Okay, so over here we're given the point, which is -2 and 3, and we've given the equation y is equal to 3x plus 8. What we need to do is we need to substitute the x coordinate to the x value and the y coordinate to the y value and see if they're equal. Okay, let's sub it in. So we know the y value is 3 and the x value is -2. So 3 times -2 plus 8. What's 3 times -2? Which gives us 6. -6, sorry. -6 plus 8 gives us just 2. So it's not equal to 3. So the point doesn't lie on the equation, on the line. Okay, that's as easy as that. So what you do is you substitute the point into the equation of the line. If it doesn't match up, if it's not equal, then it doesn't lie on the line. If it is equal, it lies on the line. Okay. Let's have a look at the second example. So we've got this point 6 and 3 and the line here, y is equal to 2 on 3 x minus 1. Let's substitute it in. We've got 6 is equal to 2 on 3 times 6. Whoops, not 6. 3 is equal to, be careful, 3 is equal to 2 on 3 times 6 minus 1. Okay, let's do the brackets first. 2 times 6 gives us 12. 12 divided by 3 is 4. 4 minus 1 is equal to 3. Is it equal to the left-hand side? Yes, it is. So the point lies on the line. Okay, that's it. Let's keep going. Intersection of straight lines. Let's have a look at the intersection of straight lines. To find out if two lines are intersecting each other, what we need to do is we need to substitute a value from here to here. Okay? Let's do the first one, for example. So we know that y is equal to 3x plus 1, and we've got the relation over here, x plus y is equal to 5. Since we know that y is equal to 3x plus 1, we can replace this y with 3x plus 1, right? So we'll have x plus 3x plus 1 is equal to 5. Let's simplify this equation. 4x plus 1 is equal to 5. 4x is equal to 4 because we subtract 1 from both sides and divide 4 on both sides, leaving us with x is equal to 1. If x is equal to 1, we need to find the y value now. Let's substitute 1 into the x over here. 3 times 1 plus 1 gives us 4. So the point of intersection is 1 and 4. Okay? It's as easy as that. And you can always verify the coordinate by substituting the coordinates into the two equations and seeing if you get the left-hand side equal to the right-hand side for both equations. Alright, let's have a look at the gradient of a line. The gradient of a line is rise over run. So the rise will be how much the y-axis differs by, and the run will be how much the x-axis differs by. Okay, and we just divide the difference in the y values by the difference in the x values. Rise over run. Okay, let's have a look at an example over here. Let's take this one. What's the rise over here? The rise will be 3, and the run will be 5. But remember, since the slope is from left to right, on the negative slope, so slopes from left to right like this, it will be a negative gradient. Okay, that's all you need to know. But we can do this with a formula. You don't have to worry about rise over run and worrying about the negatives, because we've been given a formula, which is y2 minus y1 over x2 minus x1. Okay, we know that we can get two coordinates and find out the gradient now. Let's have a look at these two coordinates. Let's say 2 and 1 is x1 and y1, and 4 and 7 is x2 and y2. Okay, let's plug it into the formula now. What's y2? 7. What's y1? 1. So 7 minus 1 over x2 is 4, and x1 is 2. 7 minus 1 is 6. 4 minus 2 is 2. So we're left with 3. So the gradient is 3. That's all. And easy as that. Have a look at this one. Make this x1 and y1, x2 and y2. Okay, let's do, actually, what we can do is we can swap it around just to show you guys that it doesn't matter which one's x2 and x1. X2 and x1, yeah. Let's do, this is x2 and y2, x1 and y1. Okay, well, let's do y2 minus y1 first, so 3 minus 8. And then x2 minus x1, 1 minus 3. 3 minus 8 gives us negative 5. 1 minus negative 3 gives us 4. So the gradient is negative 5 over 4. See, we didn't have to worry about if it was a positive slope or a negative slope, because the formula gives us what the slope is. Okay. Let's have a look at the gradient and intercept form of a line. So this one, the m, is the gradient, okay? And the b over here is the y-intercept. Sometimes it's y is equal to mx plus c. This could be c as well. All right, and all the forms it's b, but over here we can use c as well. Okay, so when you're representing an equation of a line, what you do is you use y and give it in terms of the gradient and the y-intercept. Okay, so y is equal to mx plus c, and let's take 2 points for example. Let's say we had 0 and 5 and 2 and 7. Okay, let's do the gradient. The gradient will be 7 minus 5 divided by 2 minus 0, because it's y2 minus y1 over x2 minus x1. So we got 2 over 2, and the gradient to be 1. And we also know that the x-intercept is 5, because why? Whenever the x-coordinate is 0, the y-coordinate will be the y-intercept. So we can write our equation as y is equal to 1x plus 5, but we don't usually do 1x. We just write it as x, because it's given that the coefficient of any pronumeral by itself is 1, and plus 5. And that's our equation. Makes sense? Alrighty, let's keep going. We've got some harder applications of y is equal to mx plus b. What are they asking us to do? Find the value of m and b. This one's already in kind of the y is equal to mx plus b format. What you need to do is just change the values around to get the x term to the front and the constant to the back. When we do that, we've got m is equal to -4 and b is equal to 3. Okay, let's do this one. What we need to do here is first rearrange the equation into the y is equal to mx plus b format. So we have y is equal to -2x plus 5, because we're taking everything that's not y to the other side of the equation. So now we're left with m is equal to -2 and b is equal to 5. And that's what you do. Okay. Now let's have a look at parallel lines. Parallel lines are lines which have the same gradient. Okay. So if we have the lines 2x plus 5 and y is equal to 2x minus 2, they're parallel lines. They'll never meet and they'll have the same gradients. To find out what the gradient is, we look at the term next to x and we determine if they're the same. If they're the same, they're parallel lines. So lines that never meet, like these two lines. Say for example, we had y is equal to -2x plus 5 and y is equal to 2x plus 2. Are these parallel lines? No, because -2 is not the same as 2. Okay, as easy as that. Okay, and those are our questions. We're done with the explanation. I'll just give you one more example just so that you understand parallel lines. If we had, for example, and this, are these parallel lines? To figure that out, what we need to do is we need to rearrange this equation first. To rearrange this equation, we have to take all the non-y terms to the other side. So we'll take 3x to the other side, which makes this -3x plus 5, and divide both sides by 2. We're left with y is equal to -3 on 2x plus 5 on 2. Okay, since we now know that the value next to x, which is the gradient, is the same, we can tell that these two are parallel lines. And those are our concepts for sets 14 to 17. We'll go through the questions in the next video. Bye bye.